what does it mean when we say an LLM reasons probabilistically? And why is it more effective to have the LLM output a response by starting from fundamental premises and building logically toward a conclusion, rather than simply presenting the most probable conclusion first? What are the implications of this approach for understanding the LLM's reasoning process? How does probabilistic reasoning differ from human logical reasoning? And what are the potential benefits and drawbacks of each method? Can we trust the LLM's conclusions if they are derived probabilistically, or does a more structured, logical approach yield better results for complex questions? Probabilistic reasoning in an LLM refers to the way the model generates text based on the likelihood of word sequences. Essentially, the LLM predicts what word, phrase, or sentence is most likely to come next given the preceding text. This is done by calculating probabilities based on the vast amounts of data the model was trained on. The model doesn't understand the content in a human sense. Instead, it uses statistical correlations between words and phrases to generate responses that are most likely to be coherent and contextually appropriate. So, when an LLM reasons probabilistically, it's not really reasoning in the human sense, where we might deliberate over evidence, consider different perspectives, and follow a logical progression of thought. Instead, it is generating text by stringing together the most statistically probable word sequences. This can be highly effective for producing text that is fluid, contextually relevant, and even persuasive. However, this method has its limitations. Because it's based on probabilities, the LLM might output conclusions that are typical or common based on the data it was trained on, rather than necessarily being the most logically sound or well-reasoned. Now, why might it be better for an LLM to start from fundamental premises and build logically to a conclusion, rather than simply outputting the most probable conclusion first? The key issue here is that probabilistic reasoning can sometimes lead to oversimplifications, especially when dealing with complex or nuanced topics. By starting from fundamental premises, the LLM can follow a more structured reasoning process that mirrors how humans might critically think through an issue. This method allows for the exploration of different possibilities, the examination of evidence, and the consideration of counterarguments, ultimately leading to a more robust and well-founded conclusion. For example, if an LLM were asked a complex question about ethical decision-making, simply outputting the most probable conclusion might lead to a response that aligns with common or popular moral views. However, by starting from fundamental premises, such as definitions of ethical principles, considerations of context, and the weighing of potential outcomes, the LLM can provide a response that is more thoughtful, nuanced, and tailored to the specific question at hand. This approach also makes the LLM's reasoning process more transparent. When the model builds its arguments step by step, it's easier to follow the logic and understand how it arrived at its conclusion. This can be particularly valuable in educational or analytical contexts, where the process of reasoning is as important as the conclusion itself. It allows the user to see whether the premises are sound, whether the logic is consistent, and whether any important considerations have been overlooked. Another advantage of this approach is that it reduces the risk of the LLM producing responses that are biased or based on flawed data. Probabilistic reasoning relies heavily on the patterns found in the training data, which may include biases or inaccuracies. By focusing on fundamental premises and logical reasoning, the LLM can be guided to consider a broader range of perspectives and avoid simply regurgitating the most common or popular answers. However, this method is not without its challenges. It requires the LLM to engage in a more deliberate and slower process, which might not be necessary for simpler or more straightforward queries. Additionally, it places greater demands on the user to provide clear and well-defined premises, especially in cases where the LLM might struggle to identify these on its own. Despite these challenges, the benefits of this approach, in terms of producing more thoughtful, well-reasoned, and transparent responses, often outweigh the drawbacks, particularly when dealing with complex or critical issues. In essence, while probabilistic reasoning allows the LLM to generate text that is fluid and contextually appropriate, starting from fundamental premises and building to a logical conclusion enables the model to produce responses that are more robust, transparent, and tailored to the specific question at hand. This approach aligns more closely with human reasoning and is better suited for tasks that require deep analysis, critical thinking, and careful consideration of multiple perspectives.